Welcome. My name is Mr. Sunari, and today's lesson we will be discussing how do I solve story problems involving the volume of rectangular prisms. Before we get into today's lesson, I want to go over the difference between area and volume. Area is when we do length times width. Here in this diagram we have a length of 7 and a width of 4. When we're finding the area, we multiply 7 times 4, giving us 28 inches squared. The 2 signifies the two different dimensions we're working with, length and width. And today we're going to be looking at volume. Volume is length times width times height. Here in this figure we have a length of 10 inches, a width of 3 inches, and the height of 5 inches. When we are calculating the volume, we would have 10 times 3 times 5, which gives us 150 inches cubed, or cubic inches. And we can notice that the 3 here stands for the 3 different dimensions that we're multiplying. Now we're going to go over some questions that explore volume. The first problem says, Jeffrey's first planter is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet in the planter. What is the volume of soil in the planter? Explain your work using a diagram. So pause the video, work through this problem, and see what you come up with. It's important that you draw a diagram, a three-dimensional figure, and label the necessary information from the story to the diagram. And feel free to annotate and underline or highlight important key information from the actual story. On the next slide, we're going to go over how to work through the problem. So in this problem, we drew a diagram of the container that Jeffrey is working with. Here we have 8 feet is the length, and notice how I'm color coding each of the dimensions with yellow, blue, and green. So we have a length of 8 feet, a width of 2 feet, and a height of 3 feet. We are using the volume formula where we're doing length times width times height. We are substituting the values, so our length is 8, our width is 2, and our height is 3. When we find the volume, we're multiplying all three numbers, and we will get 48 feet cubed, or we can say 48 cubic feet. Okay, we're going to go over another problem. In problem 2, Jeffrey wants to grow some tomatoes in a large planter. The planter has a volume of 320 cubic feet. The length is 16 feet and the width is 10 feet. What would the height be? So pause the video, think about how you would work through this problem, and just like in the first problem, try to draw a diagram that might be helpful for you to answer this task. So in this problem, we notice that we are given the volume. So here we know that the whole volume is 320 cubic feet. We also know that the length is 16 feet and the width is 10 feet. Unfortunately, we do not know what the height is, but we have other information that can help us with this. So since we're dealing with volume, the first thing you want to do is to write down your formula. Here we have the volume is equal to length times width times height. We know the length is 16. We know the width is 10. We also know that the total volume is 320. We don't know the height, so we can leave that as h as our variable that we're going to solve for. When we're solving for this, we're going to multiply all the values together. 16 times 10 gives us 160. We're going to bring down the h, and then we're going to bring down the 320. In order to have h by itself, we're going to have to divide 160 on both sides. When we do that, we can isolate and have h by itself. 160 divided by 160 gives us h, and 320 divided by 160 gives us 2. The height of the planter is 2 feet. We're going to go over one more problem. Jeffrey has a planting container. The length is 6 feet, the width is double the length, and the height is 5 feet. What is the volume of the planting container? So again, pause the video, create a diagram, and see how you can work through the problem, and we'll compare your answer with the ones that I provided on the next slide. Okay, so here we know some information. Jeffrey has a planting container. The width is 6 feet, so we can label that here. The length is double the width. So if we know that the width is 6 feet, double means multiply by 2. So that tells us that if the width is 6, we're going to multiply by 2 to get the length. Therefore, our length is 12 feet. The height is 5 feet, so we can label that, and we can plug that information into our volume formula. When we do that, we have 12 times 6 times 3, which gives us 360 feet cubed, or 360 cubic feet. And that would be our answer here. Finally, we're going to go into our summarization. To summarize, how do I solve story problems involving the volume of rectangular prisms? First, read the story problem to understand it. Draw and label a diagram. Know what the missing information. So here is an example. We have a problem and we have steps working through the problem to arrive at the missing height that's listed here. Hope this was helpful and have a great day.